In this module, we'll look at some economic applications of integration. We'll mainly look at how we can calculate consumer surplus and producer surplus. You should have come across these concepts in microeconomics. However, let's go over the main points to refresh our memories. We have a market for a particular good, represented by the demand and supply curves. Remember, these are inverse demand and supply functions. We have an equilibrium price, P star, and a corresponding equilibrium quantity, Q star. Now, there are some consumers who are willing to pay more than P star for this good. For example, at this point here, consumers are willing to pay P1, but the market price is P star. The amount consumers are willing to pay is a measure of the benefit they receive from this good. That being the case, for those consumers who are willing to pay more than P star, the benefit from consuming the good exceeds the cost. Consumer surplus, then, is a measure of this extra benefit that all consumers in this market receive in excess of the cost. It's the shaded area between the demand curve and P star. As we'll see in a moment, there's a corresponding surplus for producers. Welfare economics is concerned with changes in consumer surplus and producer surplus. However, we'll leave that topic for other courses. What we're interested in here is how to measure consumer surplus, given that we have a demand function. One way to do that is to integrate the function dq minus p. That's what we have here. That's a function that's the difference between the demand function and that constant price. We can expand that and take two definite integrals. So we have the area under the demand function minus the integral from 0 to q star of p star dq. Well, this second term is just the green rectangle under p star. As we know, the area of a rectangle is the product of the two sides, p star times q star. Or we can think about it in terms of the integral. So the integral of p star dq from 0 to q star will be p star times q star, so p star is a constant, minus p star times 0, p star times q star. So we find the consumer surplus by integrating under the demand function from 0 to q star, and then subtracting the green rectangle p star q star. The producer surplus is a similar concept on the supply side. The price that producers are willing to supply at is given by the supply curve. The price they receive is P star. So we see that some producers are willing to supply at prices lower than the prevailing equilibrium price. For example, at this point. The difference between the equilibrium price and the price on the supply curve is the benefit gained by producers in excess of the cost. Producer surplus, then, is the shaded area. We can find the shaded area by taking the green rectangle, P star times Q star, and this time subtracting the area under the supply curve, this area here. Once again, we have two ways of looking at the integral. We can integrate the function from 0 to q star of p star minus s of q dq. Or we can think about it as the green rectangle, p star times q star, minus the area under the supply curve, the integral from 0 to q star of sq dq. Once we have our demand and supply functions, finding the consumer surplus and producer surplus is a matter of finding the equilibrium price and quantity and then applying these formulas. But remember, we always use the inverse demand and supply functions. In other words, we have price as a function of quantity. Let's put that into practice in example 11. We're given a demand function, a supply function, and our task is to determine consumer surplus and producer surplus at equilibrium. The first thing to notice is the form of our demand and supply functions. In both cases, we have quantity as a function of price. If we plot those, we'll see we would have price on the horizontal axis and quantity on the vertical axis. However, when we determine consumer surplus and producer surplus, we use the Marshallian supply and demand diagram. In that case, quantity is on the horizontal axis and price is on the vertical axis. In other words, what we need to find first are the inverse demand function and the inverse supply function. We start with our demand function as a function of price and solve for P. We multiply through by P. We'll have PQ is equal to 90 minus 2P. PQ plus 2P is equal to 90. Therefore, P is equal to 90 on Q plus 2. And now for the inverse supply function. We start with Q equals P minus 1 and solve for P, which is quite straightforward. We'll have P is equal to Q plus 1. Now we can solve for our equilibrium values of quantity and price. We have our equilibrium condition, our inverse supply function, Ps of Q is equal to our inverse demand function, Pd of Q. Q plus 1 is equal to 90 on Q plus 2. That implies Q plus 1 times Q plus 2 is equal to 90. So we have a quadratic here. It'll be Q squared plus 3Q plus 2 is equal to 90. Subtract 90 from both sides and then we can solve for Q. That gives us Q squared plus 3Q minus 88 is equal to 0. Do we want to solve for Q? We'll use the quadratic formula. We have the general form of our formula there, substituting in the appropriate values. Well, that implies that Q is equal to minus 11, or Q is equal to 8. Quantity is greater than or equal to 0. In other words, we can't have a negative value for quantity. So therefore, our equilibrium quantity, we'll call that Q star, is equal to 8. From our inverse supply function, we'll have P star is equal to Q star plus 1. That is 8 plus 1, 9. So we have P star, Q star, our equilibrium values equal to 9, 8. Now we have all the information required to calculate the consumer surplus and the producer surplus. Recall that to find the consumer surplus, we take the area under the demand function from 0 to Q star, that's this integral here, and then we subtract the green rectangle, P star times Q star. Consumer surplus is the integral from 0 to Q star of our inverse demand function of minus P star times Q star. That's the integral from 0 to 8 of 90 over Q plus 2 dq minus 8 times 9. We can simplify that. We have a quotient where the numerator is the first root of the denominator. So we can apply the integration by substitution rule for a quotient. And we'll have 90 times the log of Q plus 2 evaluated from 0 to 8 minus 72. That is 90 times the log of Q plus 2, which is 10, minus 90 times the log of 2 minus 72. Rounding to one decimal place, that gives us 207.2 minus 62.4 minus 72, and that's equal to 72.8. Recall producer surplus is the shaded area here. In this case we start with the green rectangle, P star times Q star, and then we subtract the area under the supply curve. That's the integral from 0 to Q star of S of Q. And then what we're left with is the shaded area. Producer surplus is equal to the equilibrium price times the equilibrium quantity minus the integral of the inverse supply function, S of Q dq, evaluated from 0 to Q star. In this example, that will be 8 times 9 minus the integral from 0 to 8 of Q plus 1 times dq. It's equal to 72 minus 1/2 Q squared plus Q evaluated from 0 to 8. That's 72 minus 1/2 8 squared minus 8 minus 0, and that's equal to 32. And finally, stating our answers, consumer surplus is 72.8, and as we just found, producer surplus is 32. We finish up this module with an example that combines integration with problem solving. A country's marginal propensity to consume is given by this function, 5 over y plus 2 squared. Remember that the marginal propensity to save is the proportion of each additional unit of income that's saved. It's also the first root of the saving function. Our problem is to find the value of y when saving is equal to 0. We're given some extra information to help us do that. When national income, y, is equal to 8 billion, consumption is 7.5 billion. Let's see how we solve this problem. The first thing to do is get all our information in a clear form. The problem is to find y when national saving is 0. We're given some information. Well, first of all, we know that national income is equal to consumption plus saving. That's an identity. When y equals 8 billion, consumption equals 7.5 billion. That implies when y equals 8 billion, saving is equal to 0.5 billion. We also have marginal propensity to save is equal to dy ds is equal to 5 over y plus 2 squared. How are we going to solve this? We'll go through 3 steps. The first step is to find the saving function as an indefinite integral. The next step is to use this information to solve the constant of integration and so find the complete saving function. The third step then is to solve for y when s equals 0. We'll apply integration by substitution, where after the integral of 5 on y plus 2 squared dy, let u equal y plus 2. That implies du is equal to dy. So the integral of 5y plus 2 squared dy is equivalent to taking the constant outside the integral, 5 times the integral of 1 over u squared du. Well, that's equal to 5 times minus 1 times u to the minus 1, plus the constant of integration. Since we already have c as consumption, let's call our constant of integration s subscript 0. Substituting back in for u, that gives us the saving function is equal to s subscript 0 minus 5 on y plus 2. We have our saving function with the unknown constant. We know that s is equal to 0.5 billion when y is equal to 8 billion. We substitute in to solve for s naught. Solving for that, we have s naught is equal to 1. Therefore, the saving function, s is equal to 1 minus 5 on y plus 2. That was step 2 of our process. The next step is to find y when s equals 0. If s equals 0, that implies that 0 is equal to 1 minus 5 on y plus 2. That implies that y is equal to 3. And so we write our conclusions. When national saving is 0, national income is 3 billion.